Then this is the third model, and these are the 4 models. So other models are the subset of this. Okay. If any problem, you can decide how to proceed. Then you can find the dual. Okay. But these are the major model. So in the first model, objective function is maximization type. Constants are all less than equal type, and decision variables are non-negative. In the second model, objective function is maximization type. Constants are equally type, and decision variables are non-negative. In third model, objective function is maximization type. The constants are less than equal type, and decision variables are free. Free means it can take positive value, negative value, zero value. And the fourth one, objective function is maximization type, and constants are equally type, decision variable is free. So if it is minimization type, you can also find the dual correspondingly, because maximization generally primal, minimization is dual. If minimization is primal, maximization is dual, vice versa. Okay. So this actually before after completing, I will give you all the relationship between the primal and the dual. Okay. And there are 4 models. If I am presenting one model, the first model, other model you can derive automatically. Okay. So if you like, I can cover all the 4 models or only first model. Okay. So I think it is better I will present all the 4 models. Okay. So you can also realize, say, how we are establishing the primal and the dual from the method of Lagrange multipliers. And as I told, to solve the linear programming problem, we are solving the linear programming problem. First method is graphical method, only for 2 variables. Then the simplex method, that we are naming as primal simplex. Primal means problem is maximization type, constants are less than equal type, and decision variables are greater than equal type. Then we have big M method. Then we have 2-phase simplex method. Then we have the dual simplex. Primal with respect to dual. If primal is female and the dual is primal is male, dual is female. If primal is female, the dual is male. You can think something like, so you can say that there are 2 pairs of problem. So because they have some relationship. Okay, relationship. So the primal variable with respect to primal variables, you will have the dual constants. With respect to the primal and a constant, then you have the dual variables. Primal objective function, dual objective function, maximization, minimum, like that. So if you solve a dozen of problem, then you will realize from one problem you cannot. Okay. So I should give time, nearly 1 week to spend. This is a very interesting topic. So in the nonlinear programming also the primal dual relationship is there, but this is the it is not available in the generally in the book. They write this is the primal, this is the dual, but how to derive generally not available. Okay, so you be careful, and if you have any doubt you can ask. I was telling also for the interior point method, so you can use Narendra's Karmakar's the algorithm, okay, for the linear programming. So this is out of, this is not there in the syllabus, it is there in the optimization technique in the new syllabus. Okay, so we have already planned, but those students are interested, okay, so I can share the file, that is the PDF file. Generally nowadays everything one has to purchase. So even the YouTube file also you cannot download because so much restriction. Everywhere they want money. Okay, so nothing is free. Earlier everything was free, now nothing is free. So if really you need the interior point method, I am sure all the computer science students you need it, because you must know almost all algorithms. Then you can apply your mind how to solve and how to find a optimum methods to write a code. Okay. What I'm saying, and if you are really interested, even a chemistry students also may like, but no harm, so I will not restrict. So if you like, you please send a mail to my address. Okay, mpvisual@maths.iit or that IIT department address. You send a mail, sir, I want the code. Okay, code means you want that paper. You can write your code, own code. I don't have any code, so you have to write code. Okay, so but I will guide you how to write. How to write means what are the steps you should follow. It is not very easy to understand, so you will take at least 2-3 days to understand the paper. Okay, so if you are really like, you can send mail, I will send to you. Okay, and if you do not like, because I don't want to circulate to all, so all means somebody is not interested, why should I circulate? Because I don't have a right to circulate. Only if somebody is really interested, I can. Okay, because for example, nothing, even if you purchase in a PDF file, a book, you cannot share it. You can share with your friend, but you cannot share to public. It is a crime. Okay, so since what you are doing, everybody is able to know. So we should not, because since I am a teacher, because my email ID, my address is available to everybody. They can come and ask me several questions. So I have to reply. So I don't want to. Okay, even almost every book I have purchased and PDF files are available, but I cannot share it. But if you want, I can give you a few pages. I cannot share the whole book. So you can find somewhere, but then if you am giving, then you will say that sir has given. Okay, that is not fair. So if really you are interested in that code, which is that paper, you can send a mail. Okay, so I will send. Okay, write your email ID and the telephone number. Okay, so I can say that I have given you, no problem. Okay, so but this slide, what we are covering, so I will, after today's class, I can share, so that because you have 7 days, you can just at least go through. Okay, so these are the 4 model. First model we like to discuss. So I have told already primal simplex, dual simplex we will have not discussed. We will discuss. This is very interesting. In the dual simplex, please remember, artificial variables are not there. Big M method is not required. So it's a very tricky method. So whatever you do in the primal simplex, you will do the reverse one. For example, so for the primal simplex, our key element is positive. For the dual simplex, key element is negative. Okay, something like some people they use right hand, some people they use left hand. So just everything reverse. Okay, and there, we talk about the indicator row, but in the dual we talk about the right hand side elements. Okay, there is a difference. I will explain. So then two-phase simplex method is very interesting. Revised simplex method is most interesting because generally it is used in the writing code. Revised simplex method, we are using a special type of inverse. Then the interior point method, it is really superior and it's really very interesting. So you can go through. I hope you must have read about the Karmakars CV. So I will, if you are interested, I can share the paper. Okay, the Karmakars paper of 1984. Okay, so this is the problem in the matrix format. This is the problem. Maximization type. The constants are less than equal type. Decision variables are non-negative, and there are m number of constants and n number of variables. This is a symmetric problem. The dual, if primal is symmetric here, it is symmetric. Dual is symmetric. But second case, third case, fourth case, they are not symmetric. Why symmetric? The x is, the primal variable is non-negative, dual variable is non-negative. In case of model 2, model 3, model 4, they are different. Okay, why it is different? So they are non-symmetric model and the first model is symmetric model. Okay, symmetric, non-symmetric. Okay, this is the matrix format and this is the expanded notation. Okay, the objective function instead of z I am giving as f. Generally f is a function, maybe linear, non-linear, but so I am saying it is a function of several variable, function of x. So this is the primal problem in the expanded form. So this is the dual problem in the matrix form. Primal is maximization type, dual is minimization type, dual constants are greater than equal type, dual variables are non-negative, and here also there are n number of variables. Here n number of constants. There are m number of constants in the primal. So here m number of dual variables. Primal, dual, primal constant, primal objective function, dual objective function. So you have to remember so many things. Okay, primal, dual. Okay, this. Then This is the expanded notation. Okay. Now, with respect to the expanded notation, we have the Lagrange function. Okay. So the question is how to find the dual of a linear programming problem. We use Lagrange multipliers method to establish the dual. Okay. So details are like this. So always change a maximization type problem into minimization type. Okay. And the constraints you make equally type. Auxiliary function, minimization type, constraints, all constraints after introducing slack variables, no surplus, no artificial slack variables. So we'll change the constraint into equality type. For this inequation type constraints, the multipliers are non-negative. For the inequation type constraints, the multipliers are non-negative. For equality type constraints, the multipliers are free. For the equality type constraints, multipliers are free. For the inequality type constraints, the multipliers are non-negative. So here the variables are non-negative, that is also constraints. And generally, you must have observed when you are solving a set of equation Ax equal to b, a system of linear equation, if it has solution, the solution is sometimes unique, sometimes infinite, sometimes no solution, sometimes zero solution. Zero solution, we say that systems are homogeneous. Here systems are non-homogeneous. If right hand side all b are zero, then zero is also a solution. But here the system is non-homogeneous. And if nothing is mentioned about x, then x is a free vector and x1, x2, xn, they are free variables. Free variables mean they can be zero, they can be positive, they can be negative. And if there are free variables, what you should do? So you can transfer into greater than equal to type variables. How? One variable, let us say x is free. So you can write x equal to, so x in terms of two different variables. Let me say p and q, x equal to p minus q. P is non-negative, q is non-negative, then x is free. So what about p and q? P and q are non-negative. So if they are equal, then zero. If first is larger, then positive. If first is smaller, then it is negative. So we write in this form. So p and q will not use because we have n number of variables. N number of variables. N may be 2, maybe 3, maybe 2000, maybe 2 lakhs. So that is the reason we have to use subscript, superscript. You know, since you are the computer science students, you know why you need index, why you need array. So array is required because many names you can generate. Okay, because if you say I'm PQ st like that, if I'm saying, then there are 26 only. But here you have too many. So maybe 1000, maybe lakh, etc. So you have to use in this manner. Here P, capital P is a primal program, capital D is a dual program. P and Q. Okay. After adding slug variables, generally linear programming slug variables are, we are naming as SI, and we are saying SI is non-negative. But here slug variables are saying SI square. S can be anything, but SI square is always non-negative. So that constant in equation you can write summation over j varies from 1 to n, aij xj plus SI square minus bi equal to 0. It is a equal type. Right hand side always make it 0. And similarly, xj greater than equal to 0, this will be minus xj less than equal to 0, then minus xj plus tj square equal to 0, and this tj square is slug variables. So now if I am counting how many variables are there, SI square, m number, then p, that is xj, n in number, then tj, n in number, and you count how many are there. So, and of course, with respect to the constraints, we have the multipliers. Okay, the multipliers are lambda and mu. So as a result, lambda and mu, lambda m in number, mu n in number, total is m plus n, then x n in number, s m in number, t n in number. So now if you count, then n plus n plus n, 3n, m plus m, 2n. m plus m, 2m plus 3n. These many variables will deal. Okay. We will take care of all the variables. So our Lagrange function is something like minus. Why minus? Because we have changed maximization to minimization. Minus. Summation over j varies from 1 to n, cj xj. Summation over I varies from 1 to m, lambda times. Summation over j varies from n to n, aij xj plus si square minus bi. Here this lambda is free if the constant is equally type. But here, okay, because we have introduced some slack variables, after that it is becoming equally type. So here the condition, there are some theorems. From the theorem, this lambda 1, lambda 2 up to lambda m, they are non-negative. This lambda 1, lambda 2, lambda m in future we will name as y1, y2 up to ym. Actually, these are the dual variables. This mu1, mu2, mu_n. These variables somehow we are not using, it is suppressed. Okay, so how it is suppressed, I will tell you. So this lambda 1, lambda 2, lambda m are the dual variables. So technically you can name them as y1, y2 up to ym. Okay, this. So now method of Lagrange multipliers say that we have to use necessary and sufficient condition. Since they are linear function, only si square and tj square, they are non-linear, rest are linear. Okay, so first derivative is enough. Okay, second derivative we are not going to use. So using first derivative, we will find some relationship. So these are the conditions you have to use to establish the dual. Okay, so altogether in the problem, as I told, that is m number of lambda, n number of mu, these are the multipliers, they are non-negative. Total number of variables twice m plus thrice n, and there are m plus n number of Lagrange multipliers, they are non-negative. Using the necessary condition for the minimum. Necessary condition for the minimum say the Lagrange function L, we have to take partial derivative with respect to xj, with respect to tj, with respect to lambda I, with respect to si. 1, 2, 3, 4, and one more. So we are saying with respect to xj, with respect to lambda I, with respect to si, so 3, with respect to mu j, say 4, and with respect to tj, so 5. So we have 5 equations. Okay, that 5 equation will simplify with respect to xj, with respect to lambda I, so with respect to si, with respect to mu j, with respect to tj. Okay, 5 such equation. These 5 such equation, after taking derivatives, will simplify. Okay, in this manner. So first one, we are taking derivative with respect to xj. So del L, partial derivatives. Why partial derivative? Because it is function of several variables. Variables are, because generally you say several variables. So x, y, z, something like that. Here the variables are their vector x, s, t, lambda, mu. Okay, x has n number of components, s m number of components, t n number of components, lambda m number of components, mu n number. Okay, so now if you take derivatives, you will have like this: minus cj plus summation over I varies from 1 to m lambda I into aij minus mu j equal to 0. Minus mu j equal to 0. Okay, so here we will keep something in the left hand side, something in the right hand side. We are taking mu j to right hand side. So summation over I varies from 1 to m lambda I aij minus cj equal to mu j. But this mu j, already we have declared this mu j. You can see here the mu1, mu2 up to mu_n, they are mu j, they are non-negative, 0 or positive. So since they are non-negative, we can write this equation is now becoming an inequation. I varies from 1 to m lambda I into aij minus cj greater than or equal to 0. Greater than or equal to 0. This says summation over I varies from 1 to m lambda I aij greater than or equal to cj, j varies from 1 to n. This is a constraint. This will establish as dual constraint, and lambda this lambda I we can name as yi. So in future, we'll put a new name, the lambda I equal to yi. Okay, because when we are saying x and y, okay, so something like, if the husband name is Raja, the wife name is Rani. If she is not Rani, we'll rename as Rani. Okay, so like that. Because if you say here something like X, if you are naming as king Raja, then the Y will be Rani. Something like, okay, X and Y. Okay, then P and Q. Then something like that, I and J, like that. So you can name I varies from 1 to m, lambda I into Aij greater than or equal to Cj. Okay, so nothing mentioned about that, but this, Cj, whether positive, negative, the components, but generally, so this is becoming a inequation of type 2 greater than or equal to type inequation. Then how many numbers? N in numbers. Earlier, for the primal constants, there was the m in number, now it is n in number. Okay, so lambda equal to yi. First part is over. Now we are coming to partial derivative with respect to second, let us say lambda I, m in number, del lambda I equal to 0, I varies from 1 to m. This says summation over j varies from 1 to n, aij xj plus si square minus bi equal to 0. Okay, so but as I told, this si square is non-negative, so you can remove this. After removing, you will find the original constant. What are the original constants? Summation over j varies from 1 to n, aij xj less than or equal to bi. So after taking derivative, whatever you get, so we are simplifying. So this equation number 4 is nothing but the constraint of the primal program. We have established constraints of the dual program, and we have established constraints of the primal program. Okay, 3 and 4. Is all right? Or any problem? Hello?
Hello, sir.
Any problem you face?
I have a doubt. Why are we differentiating and placing it equal to 0? Like object.
See, Baba, I'm telling whether your teacher has covered the method of Lagrange multiplier or not, you have learned that is or not. So I am not going to teach you about the mathematics. Mathematics 1. So if you have not learned, please go through. Okay, or I will give you some materials. Okay, this. So method of Lagrange multipliers. In calculus, this is a topic to solve some minimization maximization problem. See, in the +2 level, when you maximize and minimize a function of single variable, function of x, only single variables, what do you do? Generally, that function is not a linear function. It is a nonlinear function. So for necessary condition, what is the necessary condition? First derivative, 0. Then what is the sufficient condition? You go for second derivatives. So once you set this necessary condition, the derivative equal to 0, we find some critical points. So after finding the second derivatives, we find the value of the function, okay, second derivatives at that critical points. If that is becoming positive, then it is minimum. That is becoming negative, then it is maximum. That is becoming 0, we cannot say anything. Okay, that you have. But if it is function of one variable, if it is two variables, we have to use for the second derivative. So we have to use a Hessian matrix. Okay, so that function you have to take derivative with respect to x1, with respect to x2, then second derivative with respect to x1 twice, with respect to x2 twice, then with respect to x1, x2 partial derivatives, with respect to x2, x1, something like that. So we'll have a 2 by 2 matrix or determinant. So there you can check about the Hessian matrix. But here is a function of how many variables? How many variables? Twice m plus thrice n. You cannot dream. If I'm saying m equal to 10 and n equal to 10, how many are there? 2 plus 3, 5 into 10, 50 variables. Okay, 50 variables. If m and n, let us say 100, 500 variables. What you will do? You know the method, but you don't have any option to derive. Okay, so there maybe your coding will help. Okay, so that is reason we are talking about the a smaller size problem, and here these functions are linear. So we will find a dual problem which is also linear. Okay, so that is the reason we are taking only using necessary condition. You have the Piskunov book, you have the calculus, that book by Joan Iyengar Jain. I will tell you one thing. You in the tech market itself, there are some books, old books they are selling old book. Okay, they're selling old books, yes or no? Hello, are you able to hear?
Yes, sir.
They are selling old books, but really, if you want to build your career in your subject, in physics, chemistry, mathematics, engineering, don't sell the books whatever you have used and purchased. Don't sell it, and try to keep the hard copy in your almirah and soft copy in your laptop or your mobile. Okay, soft copy only to see, hard copy will read. The soft copy is soft copy. Okay, something like see and forget. So, but the hard copy remain. The hard copy remain forever. Okay, so you will surprise know. I was doing PhD in some nonlinear programming topic. Okay, that time in our Kharagpur library, one book was available, only one copy. So people were really searching that book, whether it's who has issued, so available or not, like that. So something happened. My daughter is presently at US doing her PhD. So I asked whether this book is available to purchase after 30 years. So whether this book I can purchase or not. Told yes, available. But now, so many books are available. They are selling because they don't have space to preserve the book. So if you like, I can buy for you. She purchased that book. That book is so useful. Which thing I was not able to study, now I'm saying it's really, really interesting. Some problem I will take Xerox, and some engineering problem, some Xerox I will take it and I will give all the students, okay, to formulate the linear programming model. Okay, some mechanics is there, because I don't know much mechanics, so you will understand and you will explain me. Once you can formulate the model as a linear programming model, then you can solve. First thing, how to formulate, and I have given a slide, the model formulation. Okay, that actually I am supposed to cover in the first class, so I will cover after some time. The reason is because when you understand something, then you like to know, yes, how the model is useful. One model about the furniture, hostel furniture. Another model in some some small company, it's hiring engineers, he can, okay, 2-3 models are there. So very interesting. One is continuous, another is discrete. So, and we like to discuss. So because this I am hurriedly covering because I like to take a test. And he said that unless I fix early, I will not get the slot. Okay, if I cannot get the slot, I cannot conduct the test. And your test will be conducted on the module. Module, okay, already I have sent your roll number, etc. So they will send the link to you. Okay, so in the first test, you may not get the link also, but I will be available online to help you. So if you are not getting the link, you can call me. I will, you will note down my number and call me. Then I will ask him. He will send the link to you. Module. Okay, the object I test, and the tests. The problems are very interesting. So here you have to independently try. But if you are making a group and trying, you will get lost. Okay. So, and I'm telling here, suppose say the test I'm conducting out of 30. Okay. If the highest mark is 5, I will make it 30. Okay. If For example, if you are getting, all you have copied, you got all 30. Okay, so then I will find a way to reduce your mark. Okay, so because I am conducting several tests, so you have to do independently. Okay, but see, these three problems, it will take for a very good student 30 minutes. Very good student 30 minutes. And a poor student should solve the problem in 1 hour. Okay, but we are giving 30 minutes. So 30 minutes solving a problem. So suddenly I will not be able to solve all the three problems in 30 minutes. So I will take at least 1 hour. But it is given to you because you are hero, no? Because you have qualified JEE, so you know many things. Maybe many answer you can, without calculating, you can find the answer. Okay, so and that too, everything now you are solving problem. Sometimes you are solving, sometimes your parents are solving, sometimes your friends are solving. Who is solving, you don't know. So our question is easy but very tricky question. So you have to understand. Okay, and you will understand if you are reading thoroughly. If you are not reading thoroughly, you are nowhere. Okay, I'm telling. So you may get 30, hardly matters. Even I'm telling, out of 150 students, if 100 students get, so or 50 students get excellence, there is no harm. So they are good students, and your CGPA is 8.5, means almost every student you are supposed to get at least A. Okay, that is the the procedure we are following. So I have to see that yes, you are doing, and many you are not coming and you are writing for the attendance. So suddenly I am giving attendance, but your your rank will be decided on your coding. And coding will say whether you will get excellent or A or B or C or P. Okay, even the tests are there. I have to be, even sometimes I may call you and take the interview. Okay, whether you have understood the problem or not. Right? So be careful. And what I'm saying here, now this is the time to learn, and you are getting plenty of times because you know where you are traveling. You are at the hostel. Okay, so spend time and learn as much as possible. This is the time. But not telling that you should read 20, all the 12 hours. So at least 8 hours if you are working. So work in a proper manner. Okay. But if you are asking question, then you are interested to know. If you are not asking question, you are not thinking about anything. Okay. But that is not fair. Since you have come to a good place, so you ask question, interact, and do your problem and ask somebody, sir, yes, whether it is correct or wrong. But nowadays, many people, what they, you get something, you search in the net, whether it is available or not. But that you should not do it. You should not do it. Say, I have searched, you ask me where I will get, I will tell you. Okay. But you don't search it. If you search, say, even sometimes you will lose 3-4 hours for searching small things. But don't do that. Okay. So you try yourself. And you ask me what is the textbook I should. And in that note also you can see 2-3 textbooks. You have got the textbook. One is by H. Taha, operations by Taha. Everybody should have. Engineering optimization, whatever given, that is everybody should have. And if you find some other books are there, but they are costly books, you may not be able to find. But you may not be able to find out from the tech market also. But I find, some library books are also available in the tech market. Stamped in the library stamp is available. The book Mala told, sir, this is a library book available, we want to purchase. I told, I cannot do that crime. He told, sir, somebody has already paid. You have paid the book, paid 2-3 times. The book cost is 500 rupees, you have paid 2000 rupees. Now you are selling. You are great. You are great. And library books, you should not. Okay. You should, if you have already, you look at the book and book is with you, you keep it. Okay, so that you remember that yes, I have paid the fine and which book is with mine. Okay, so this is a international edition and printing is like that. But don't sell it. See, you may sell your old bicycle, all right. You may sell your old, bed, etc., bedroll, etc. But don't sell the book. You can sell your notebook. Don't sell the book. At least some of the textbook you keep it forever. And if you are, for example, you are going to start some startup, there you don't need anything, then it's fine. But if you are going to learn something, I think the book is useful. For example, Advanced Engineering Mathematics, Krajcik. You know it? You know that book, Krajcik?
Yes, sir.
That is a book no engineer can forget. Okay, And there are several other books are there, but that is well written and well placed. Okay, everybody will be able to understand. Okay, and you can see there are some problems are given odd and even. Okay, so why odd even? At least some problems you will try yourself, odd even. Otherwise, if all the problems having answer means you will not try. Okay, like that. But I'm telling, don't throw it. And nowadays I'm telling the lady students are doing better because they are learning the subject thoroughly. Learning. Even I'm telling gents are also super, but not all. They are in a different mood. They are in different mind. I should not study, but I want to earn monthly income should be 1 crore. You don't need 1 crore. Why you need 1 crore? 1 lakh is enough, not 1 crore. Okay. When we joined in job, our salary was only 2,000 rupees. 2,000 rupees. That was enough. Okay. But if you earn more, you will spend like anything. You will not bother. Okay. You will not bother about anything. So you will purchase and throw. But that is not a thing. Every rupees is useful. Okay. Keep it. You just now realize the Tata. They force the teacher, you have to travel by Air India. Air India. See, if you are traveling, you are going to USA, you will not feel to take Air India because it is not safer. You will think to travel by a American Airlines. They are forcing us, you travel by Air India. Pay more, but the facility is less. Okay. Finally, they are sold to Tata. Tata will manage and it will be a dependable airline. Okay, dependable airline. Why? Because see, there, since government money, everybody, will just like to spoil. We don't want to improve, but try to do something. Okay, so that you see, Air India now, I don't know what name they will put. Tata will put Air India some other name. Initially it was with Tata. Now it come to Government India. Then again they sold it out. Okay, so this is not fair. I'm telling why not fair? Because you see, after spending so much time, so much energy, if you do like that, finally, what is the ultimate aim? Everything is private. Everything is private. Okay. See, private people, they will count one pipe, Say, see, I'm paying electric bill for my house. So for January, bill will come in the middle of January. You pay in advance. Okay. Bill will come in the middle of January. So why, if you are getting, you see, they are getting the money in the middle of January, they are getting interest, no? See, nobody is there to argue. Nobody is there to argue. I'm telling here, see, you have got enough time to study. You are not coming to the class. Okay. See, whatever the note I have supplied, I have typed myself. And many people, you must know also, you are typing with something. I'm typing with the overlip. You are also typing. I think many students are typing the overlip, and the students suggest, sir, this is a good software you use. Okay. I am preparing my note myself. Why I am preparing? Because handwritten note, it is no way. I will throw it. At least whatever time I am spending, I can circulate. And you can have, some document you can preserve and you can read yourself. Okay. That is the reason. So every document I am typing myself, and typing a document takes time. Yes or no? Preparing 10 pages, at least you need, say, 2 to 3 hours. And if you are copying somewhere from the net, so there is difference. If you are solving a problem rightly, so you have to solve it carefully and you have to give the answer. Okay. So that I'm saying here, anything you want to do, you have to, even if you are finding a new line, you have created a new line, that is your contribution. If you have copied, 200 pages somewhere, that is not your contribution. And you will feel happy if you have done yourself. If you have copied, you should not feel happy. Okay. So we have got the dual constant, primal constants. Okay. This. Now, somebody is asking me why first derivative, why second derivative is not used. Because the function is linear, not question of second derivatives. Okay. And here SI square, actually it is linear. We have made it non-linear for some other purpose. What is the purpose? Now it is coming to the picture. Now you take differentiate with respect to SI. This Lagrange function, take derivative with respect to SI. You can see here, this is Lagrange function. If you take derivative with respect to SI, what will be the outcome? Can you tell me? There is, There are how many SI are there? There are m in number. Let us say you are taking derivative with respect to S1. Then what will happen to outcome? Just tell me.
Lambda
You
one
should
is
derive this problem yourself. Then you can understand. Okay. If you take derivative with respect to SI, how much will be there? Anybody?
2 lambda 1.
Yes. 2 lambda I into SI. Right? That is equal to 0. Right? This is the right answer. See here. We got twice into SI into lambda equal to 0. See, 2 is not 0. As a result, SI into lambda I equal to 0. If SI into lambda I equal to 0, what it indicates? The product equal to 0. Yes or no? Product equal to 0. SI into lambda equal to 0. The product 0 means both can be 0 or one of them is 0. Yes or no? Product
Yes,
equal to 0 means either SI equal to 0 or lambda equal to 0, or means both, or one of them, either S1 or SI or lambda I, this. From this, it has been adjusted. So if this equal to 0, we don't know whether S is 0 or not. I am multiplying one more S in the left hand side. What will happen to the outcome? What will happen to the outcome? SI square into lambda I equal to 0. SI square into lambda I equal to 0. What is SI square? Now let us find out. What is SI square? Here. What is SI square from this? Above equation number 4. What is SI square? Keep SI square in the left hand side. Take everything to right hand side. What is SI square?
BI minus summation.
BI minus summation over j equal to 1 to n Aij xj. Okay. SI square equal to this. Okay. So I am writing same manner here. So lambda I equal to SI square, that is BI. See that minus sign if you multiply, because you know lambda I into SI square equal to 0. Minus lambda I into SI square equal to 0. If you multiply minus. So that is the reason I am writing. So lambda I, okay, you see here lambda I, BI minus summation over j varies from 1 to n Aij xj, this equal to 0. If this product equal to 0, what it indicates? They are actually the complementary pair. With respect to the ith constants, this is the ith dual variables. Their product equal to 0. With respect to the ith dual variables, we have ith constants. That difference means either this equal to 0 or this equal to 0 or both can be 0. Okay, this you are writing. These are the complementary pair. Okay, now this work is over. Now you take derivative with respect to mu j. If you take derivative with respect to mu j, what will happen? What is the outcome? Mu j. Tell me how much? If you take derivative with respect to mu j, what will happen? Minus xj plus tj square equal to 0. Now we are getting that minus xj plus tj square equal to 0. That indicates xj equal to tj square. One side xj, other side tj square. Then, so here we are keeping as it is. Then we take derivative with respect to tj. Partial derivative with respect to tj. So if you take derivative with respect to tj, what will happen here? How much? Very similar to SI square. How much? Derivative with respect to tj square. Tj, not tj square, tj. How much? That is twice into mu j
TJ.
into tj. Same thing here. Twice into mu j into tj. That is equal to 0. That indicates mu j into tj equal to 0. That indicates mu j into tj square. I am multiplying tj forcibly to the left hand side. Mu j into tj square equal to 0. What is tj square? Tj square equal to xj. So as a result, you are finding mu j into xj equal to their product equal to 0. Okay. Equation number 6. Very interesting. Mu j into xj. What is mu j? Mu j is a multiplier. Okay. That multiplier somehow we are removing. Okay. And into xj equal to 0. Now this is the picture. summation over I varies from 1 to m lambda I aij minus cj equal to mu j. This you have already got. This is okay. This equal to mu j. You can see summation over I varies from 1 to m lambda I aij minus cj equal to mu j greater than equal to 0. So that we are using. So if you use, summation over I varies from 1 to m lambda I aij minus cj equal to mu j. But you see here, this mu j, I have told the mu j is a multiplier that is non-negative. So from this you can write in this manner. So right hand side will be, instead of equation, this will be greater than equal to 0. If that is greater than equal to 0, you take cj to the right hand side, then you change the side. So you have here cj less than equal to summation over I varies from 1 to m lambda I into aij. Now you verify whether from these two equations, the previous two equations, whether you can establish this or not. Check. You can establish or not. If you say yes, then we will proceed. Tell me quickly. Because you see what I am doing here. So the right hand side is mu j. Take this cj to the right hand side. So this will be greater than equal to cj. The left hand side is more and right hand side is less. Okay. So I am changing the side. So right hand side is more, left hand side is less. Okay. Right. This once you have got this, so now we are going in a backward manner. Now we know our decision variable xj is given non-negative. Now with this inequation, multiply xj in the left hand side. So if you multiply, what will happen here? Cj into xj multiply this inequation, since it is a positive quantity, non-negative, the inequation remain. Yes or no? From this cj less than equal to this, you are multiplying xj, xj less than equal to this. So after that, you sum it. There are n such terms. Take summation. Summation over j varies from 1 to n, cj xj less than equal to j varies from 1 to n. Okay. This quantity multiplied with xj. Then there is a trick. We can interchange. There are two summations. J varies from 1 to n, I varies from 1 to m. We can interchange the summation. Okay. You can see here. So if you interchange the summation, we have here summation over j varies from 1 to n, cj xj less than equal to I varies from 1 to m. There is j varies from 1 to n, aij xj lambda I we are interchanging. So as a result, we have here summation over j varies from 1 to n, cj xj less than equal to this quantity. But see, summation over j varies from 1 to n, aij xj. This quantity, if you think about the constant you can see here, this is the constant, the primal constant. Summation over j varies from 1 to n, aij xj less than equal to this we are using. Okay. Bi is more and the left hand side is less. Bi is more. So here what we are using in this equation, so this quantity is cj xj less than equal to this right hand side expression. J varies from 1 to n, aij xj. Okay. This quantity. So this quantity you are replacing with a bigger quantity. If you are replacing with a bigger quantity, then the inequality remains. If you are replacing the smaller quantity, you cannot conclude like that. So Bi is more than summation over j varies from 1 to n, aij xj. So instead of j varies from 1 to n, aij xj, we are writing Bi. So as a result, we have here, you can see summation over j varies from 1 to n, cj xj less than equal to I varies from 1 to m, Bi lambda I. Okay. This lambda 1, lambda 2, lambda m's are the multipliers, also called the dual variables. Okay. Dual variables. So the dual variables I am naming as y1, y2, ym. As a result, you can have here j varies from 1 to n, cj xj less than equal to I varies from 1 to m, bi lambda yi. See, the cj xj summation over j varies from 1 to n. This is the value of the primal objective function. This is less than equal to the value of the dual objective function. C transpose x is less than equal to B transpose y. So C transpose x is F, F is less than equal to F dash. So this is our weak duality. Okay. See, now this happens, but here what technically we are doing, so this left hand side is maximization type, right hand side is minimization type. Okay. Generally, but here nothing is mentioned. This C transpose x less than equal to B transpose y. You take the maximum value. Maximum value of C transpose x is less than equal to maximum value of B transpose y. But as you know, so that maximum value is always that maximum value. Okay. So this maximum value of C transpose x. Okay. So is less than equal to maximum value. So if maximum value is less than equal to maximum value of left and right, so we are replacing with the minimum value. Then it may happen maximum value of f equal to minimum value of f dash. Okay. But here it is less than equal to. So since it is the right hand side is more, we are taking instead of maximum, take minimum. So left hand side maximum, right hand side minimum. The strong duality. So this is called the strong duality. We have the problem minimization of B transpose y, the dual objective function. These are the constants. These constants we have established. I varies from 1 to m, aij into lambda I greater than equal to cj. What about lambda I? Lambda I equal to yi, that is non-negative. This is the dual program. Okay. Now, what is the primal one? Primal one already I have told. This is the primal. So we have, with respect to the primal, we have the dual program. Okay. This is the primal, and this is the dual we have established. This one. So with respect to this, we have m plus n pairs of complementary condition. What is this? Summation over j varies from 1 to n, aij xj minus y minus bi equal to yi. Okay. Actually, this in the left hand side, we wrote something like si square into yi equal to 0. This is saying something about si square. Si square into yi equal to 0. So there are m such pair. Okay. And with respect to this, what is actually given? Summation over j varies from 1 to n, aij xj less than equal to bi, and the yi is non-negative. This both are in equation. Okay. Similarly, summation over j I varies from 1 to m, aij yi minus cj into xj equal to 0. What is this one? This is actually tj square. Okay. Tj square into xj. So tj square into xj. So this tj, finally we are writing summation over j varies from 1 to m, aij yi greater than equal to cj, and xj is non-negative. This example already have told. Already have how to solve the primal dual we have told. So we have completed only the first problem. There are several other, second, third, fourth. So if time permits, I will discuss. Okay. So otherwise directly I can go to the dual simplex method. One is enough, but I will give you all the slides, whatever is there. Okay. I am showing you what is the second problem. Second problem, objective function is maximization type. Constants are greater than equal type. Okay, decimal variables are non-negative. And what is the Lagrange function? Lagrange function, you see, since it is equally type, no question of slug variables. Everything is same. The slug variables si square we have removed. Okay, other things same, right? And proceed. Now come to third problem. Third problem. What is third problem? Second, okay. Third problem is, so objective function is maximization type. Then Ax less than or equal to B. Okay. And X is free. X is free means no slack variable, surplus variable, or we are not going to add. But Ax is less than or equal to B, you need slack variables. So what is the Lagrange function we will have here? The Lagrange function is like this. Lambda I must be there. Si must be there. But Tj mu j is not there. Tj mu j is not there. Okay. So we have here xj and the lambda I are also there. This lambda I possibly and there is, you know, with respect to this problem, there is some technical region. What is the region here? So we have the primal, no? The x is free. X is free, and but the slack variables is there. Okay, so the lambda here, one line I missed that I would change it. Okay, what is that? The lambda I, since it is in equation, the lambda I are non-negative. Okay, lambda I are non-negative. Okay, but here nothing is mentioned. Here I have to write one more line and proceed. And the fourth one is simplest of all. I will explain again, but since time is not there, I am just okay. See, x is free, x equal to b, maximization type. No slack variable. Here for the decision variable, there is no slack variable. For the constants also no slack variables. So what is the Lagrange function here? The Lagrange function, you can see here, summation over j varies from 1 to n, cj, xj, plus lambda I varies from 1 to n, and this. Lambdas are free, and x1, x2, xn are also free. Okay, this. Third, fourth, second, third, fourth, I have not discussed, but I like to discuss. Okay, so it is required, but only first model you have discussed. So this slide I will pass it today. Okay, I will flash it today, so you can go through. I will stop here today. Is it okay? See, I have solved some problem. Okay, so I will tell you from the type 1 few, from type 2 few, for the type 3 few. Okay, so you please go through and how to solve. So you have to have the method, dual simplex method. I will discuss about that. Okay. So this Monday, Tuesday gone, another Monday, Tuesday. So we like to cover by Monday. I'm thinking by Monday or Tuesday, I will cover. Today is the, what is the date? Today is first, no? So coming yes, Tuesday, 8th, isn't it? 8th. Then next yes, Tuesday. Next Tuesday, we'll have the test. 15th at 12 o'clock, we'll have the test. Test is for half an hour. If you like, you can start the test at 12 or at 12:30, but 12. Okay. So what I'm saying here, so there will be time, no? So before 5 minutes, you will open it. Okay. So by 12:30, you'll close it. And this test I am not going to conduct. I have already given the, you know, all my the question etc. So they will plan it and they will upload, and the link I will send to you and they will also send. Okay. So your roll number and your roll number valid, and if you have already registered your roll number, whatever there in the ARP, I have passed to him. Okay, the Excel file. So it may happen there is a mistake, this that. So okay. And what I'm saying here, you try the problem independently. But if you are copying, there will be problem. Problem means, so if somebody is actually know the correct answer, you will mislead him. Okay. And you do not know, it may happen. But please remember, when I'm formulating the questions, I'm using the text file only. Okay. You will have something like not x1, x subscript 1, not that, not possible. I'm writing x1 because I will give it the x1, he will write something else. So I'm writing, so x1, x in the side by side 1, 2x2 means x2. Okay, write something like that. If you're writing x22, then x22. Okay, something like that. And greater than equal to, greater symbol, then equal to symbol, not in this manner. Greater than equal to. Okay, right. And for example, I'm giving something like say A. Okay, it is capital A, not okay. If something like you have to write A, you should write everything in capital. All numerical and other characters in capital. Okay, because sometimes they are the ASCII characters, there will be some difference. Okay, so capital A and small a. Okay, so you write everything in capital. For example, my answer is capital X, capital Y, capital Z. These three characters. You don't write small xyz because then there will be two answers, small xyz and capital xyz. So you write the answer is capital X, just write capital Y, capital Z, right? Okay, so no dot, no comma, nothing. Okay, if you put that, then it is a mistake. Okay, so once you have given the answer, you cannot change it. Once you have entered so you cannot change it. So it is not allowed. Okay, so there will be this is the problem. So you be careful, and if you have doubts solving some problem, you can ask me. I have told you several tables. All the tables are useful, but I don't know which table. So first table somehow for the beginner. Then once you have crossed that stage, so you may use the extended table, but don't use. But you'll do more work. Then use condensed table. Okay, condensed table for big M method, condensed table for the 2-pi simplex method. But for the revised simplex method, the extended table is must. I have given some problems. You have seen this slide. Okay, right? Okay, thank you. So we will meet on Monday. Okay. So for example, so there is some problem and you have some doubt you want to ask me. So in some evening, okay, in some evening next week. So today is the first, Monday, Tuesday, 8th. After 8th, sometimes one evening 2 hours. Okay, maybe at 7 to 9 or 8 to 9 or 8 to 10. So I will be on online. You can ask question. Okay, right? Is it okay?
Excuse me, sir.
Huh?
Sir, in the Moodle, do we have to write the answer or do we have to upload the solution?
No, nothing. No question of uploading. Okay. The method is very simple. For example, this problem, what is the answer? Answer is 8 and 2. So my question is, what is the first component? You write 8. So what is the second component? You write 2. Okay. What is the object distribution value? You write 16. Okay, that's all. But 16 only, not 16 dot. Okay. If it is 16.5, you write 16.5. Okay. If it is 16, 16. Okay, right? Only answer. But if you are writing Z, you must write in capital. Okay. Because they will commit mistake. So I am telling you. So these are nothing. There is no secrecy. So in this. Okay. But I am giving 15 question. Each question carries 2 marks. But so there are 3 questions. In every question there are 3 parts. So something like A, B, C, D, E. So each question, each part carries 2 marks. So 15 into 2, 30. Okay. So my question is, I will take 3 tests, 30, 30, 30, 90, 10 mark, teacher's judgment. Okay, 100. Okay, that's all. And even I'm saying, I have the capacity to add also 5 marks because I get to round off your grade. But if I find that really you are good, really good in the sense your submission is good, your code writing is good, and your first test, second test, these are the consistent. In one test you wrote the answer is you got out of 30 or 10. In other states it's 29, so I don't allow. Okay, and here the mark cannot be 2 means either 0 or 2. No part marking, either 0 or 2. Okay, so only one part. Every question has one part, either 0 or 2. Okay. But I am not writing 0, 1, 2. It is either 0 or 2. That's all. Okay. So please remember. So you can remind, or Tuesday I will decide which day we are going to discuss. Okay, some session. Okay, but this and you send mail, or if you can create a group mail, all right. Okay. So group mail means all the computer science together, all the students together. Write one mail. I am sending the file to all. Okay. So because if I'm sending 160 files, I will become mad. Then I have to send to everybody. Okay. But one thing, do you all need that paper, the Karmakars paper? Tell me yes or no. If you say yes, then it's all. But if somebody says no, I don't need it. So why I should send? Okay. What you tell me? Send me a request. Okay. From the request, I will take statistics. How many are interested? Okay. See, there is some space problem in my computer. Okay, because 3,000-4,000 mails are there. They're saying delete. Okay. So generally, I read your mail and delete unless if it's very useful, I will reply. Okay, yes or no type. Okay, that's all. Thank you.
Thank you,
Is it
sir.
okay?
Thank you, sir.
And what you do, you start writing the code and make it your group. So every month there are 10 codes. Every month you can write 5. Okay. February is gone. March, April. In March 5. In April 5, every week one you can write. Okay, you plan it accordingly. See, you
Sir,
have
can
enough time,
share
but
the rule list?
if some people say no, they're saying shortage of time. So not that. You have enough time. Writing code, people write in the night, not in the morning or evening. Okay, in the night they write code. Okay, thank you. This I will send in the evening. This paper. Okay, after correction.
Sir. Sir, do we need to submit both C++ and Python codes, or only one language will suffice?
You have to give me the complete code. Okay.
Yes, sir, but only C++ code, a complete C++ code would work, sir.
Your code I will take, but I will not sell it. Okay, I have the code also. But how you are writing and which efficient method you are using, just I want to study. Okay, so that I will rank it accordingly. Okay. So
yes,
if you are
sir,
an
yes,
excellent student, you should write excellent code. If you are a poor student, you should write in a poor manner. Okay. Thank you.